Hello students, welcome to Wallah English channel. In this session, I'll be helping you to construct the DFA with the help of the composition functionality. So first I will be learning what is the composition and then how to do the finite automata composition with the help of one or more finite automata, and then we'll see how to construct the DFA with the help of the composition feature, and we'll see some of the practice questions as homework. Okay, yeah, let me begin with the what is composition. You have studied the Cartesian product of the two sets, right? So with the help of that we are going to do the composition. So if let's say you have two sets, let's say Q1 is having, let's say Q0, Q1, Q2, and others Q2 is having some elements. Okay, yeah, good evening Sima. We have two sets. Now what is the meaning of the Cartesian product of two sets? How many elements are there in this set? How many elements are there? How do we compute? There are 3 elements and 2 elements. 3 multiply with 2 will get 6 elements here, but each element is going to be a pair. Good evening Tanuj. So now there is a relation from Q1 to Q2, element of Q1 to element of Q2. So the Q0 is going to have a relation with Q0 dash or Q0 prime, and Q0 will have a relation with Q1 dash, and similarly Q1 will have a relation with Q0 dash, and then Q1 with Q1 dash, and then you have Q2 with Q0 dash and Q2 with Q1 dash. Okay, so these are the elements you have, total 6 pairs. And now I hope you understood what is a Cartesian product. So there are two kinds of Cartesian products. Whether you do Q1 with Q2, you will have this relation, and Q2 with Q1 will have a different relation, where now element of Q2 will have a relation with Q1. So the order is very important. Here Q0 dash will have a relation with Q0, similarly with Q1 and then Q2. So that Q0 dash will have the relation with 3 elements. Similarly Q1 dash will have a relation with Q0 and then Q1 and then Q2. Right. I also remember this point, the Q1 cross Q2 need not be equal to Q2 cross Q1, because if you see these two, even though we have 6 pairs here, that means 6 elements here and also 6 elements here, but they are not same. They are not same because the Q1 Q2 are not same. So Q1 cross Q2 not equal to Q2 cross Q1. Can you tell me, is this equal to, maybe you can say note, Q1 cross Q2 need not be same as, sometimes same, sometimes not, depends, need not be same as what? Q2 cross Q1. But that's the first note. And second note, the size of Q1 cross Q2 definitely equal to the size of Q2 cross Q1, and that's equal to size of Q1 multiply with Q2, size of Q2. Is it correct? So this is called as the composition of the two sets. How do you do the product, or you can say Cartesian product of two sets? Done. So using this composition principle, we are going to do, or we are going to apply for the DFAs or finite automata, right? So I hope any doubt here in this? No doubt, right? You will have the 6 elements here, 6 elements here. The size of these two Cartesian products are same, but they need not be same. These two are different, but their sizes are same. Okay. Now this principle is applied to the finite automata also. So when there is a problem which depends on many conditions, then each condition you can design one finite automata, and then if you want to do the combining of many conditions, then you can also combine the machines. So now let's look at some example to understand. Suppose I want to design a finite automata for a language which has A's and B's, where you wanted to design, like say, number of A's in a W is equal to even and number of B's in a W, let's say, odd. Then what is the meaning of even and odd? Even means divisible by 2, that's 0 mod 2, you can say that, right? If you look at 0, even means 0 mod 2 and odd means 1 mod 2. So this is a divisible by 2, number of A's is divisible by 2, and here number of B's is not divisible by 2. Yes or no? So you can design two different machines and then you can combine them, because this comma represent AND here. So individually what you can do, you want to design a finite automata for this language, so we don't do directly. So how do we do? Here we do like this. Here we design a finite automata for only this condition first, and then we will design a finite automata for this one, and here you want to combine, right, AND relation you have here. So we do Cartesian product with these two machines to get the finite automata. Of course, resultant will be a finite automata for the language L. Is that clear? How the finite automata composition works? If you have more than one condition in the language, you may use the composition principle to do the Cartesian product of various conditions. Of course, it's not the conditions. We will design the finite automata for each condition to satisfy each condition. Then we do compose of all these machines to get the new machine for the language L. If you have many conditions like this, each one you can design one finite automata. You can do two conditions at a time, and finally you can get the composition of all these machines to get one machine for L. Right, now we should know how to design a machine for this. Is that clear? What is the finite automata composition? It could be AND, or it could be OR, it could be but not. It depends on here the relation. Here a comma I have written, but in place of comma even you can have AND, OR, but not. But this comma represents AND, but in general you can use even for OR or even for but minus. That means I want this, but I don't want this condition to satisfy. So I want every string who satisfies this condition and also satisfy this condition. That's the one kind of machine we are looking at right now. Okay, let's first design for this, then apply this same composition machine or compound machine for other problems also. Okay, so how we design this? Now I'm writing again. So the language is having the strings over A's and B's. Here you want to see number of A's is even and here comma number of B's is odd. Now what you are going to do, you are going to design first, divide into two problems. So you are going to design for L1 first, that L1 is W such that W belongs to A comma B whole star, where number of A's is even. First you will design for this, and L2 is set of all strings over A's and B's, number of B's is odd. That means it's just like a divide and conquer rule. You know, if you studied algorithms, divide and conquer, right? So you divide the problem into two sub problems, then combine later. So now solve this problem separately. That's finite automata 1 we are going to design here. What is the finite automata 1? When the number of A's is even, like you can accept epsilon, and when one A comes, go to the odd state. When other A comes, go to the even state. So even is, odd is. If B's comes, that we don't care, because in this problem B's we don't have any condition, so we put a self loop. This is for number of A's is even and number of B's is odd. So now at least one B should come, that's odd B, and then after that any number of even B's will become odd. So you make a cycle like B followed by even B's will become odd. So 1B, then 3rd B, then 5th B, you will be always at final, but A's we don't care, you can have any number of A's from any state. So these are the two individual machines, they are so easy to design, yes or no? But by combining these two machines, you can build a new machine, that's FA1 cross FA2. Assume this is FA2. Okay, so now individually we are able to design. Now how to combine the two machines using Cartesian product or composition principle. Right, we divided the problem into two subproblems. Now what is the meaning of, let me copy this multiple times so that I can use this. Okay, so now what is FA1 cross FA2? What is FA1 cross FA2? See, FA1 is having the set of states here, comma, sigma is same and delta is different here, and Q naught is, just name it something like here A, B, let's say X, Y. Now what's happening here, that is here initial state is A and final states are going to be only A. So this is the finite automata parameters. Of course Q is here A comma B and sigma is here small a comma small b. Delta is already defined here, what is delta, and similarly FA2 is equal, let's say Q2 is here X comma Y and sigma is same, that is A comma B. Of course transitions are different from the other FA1 and initial state is X, the final state is here Y. Okay, I hope you have clarity what is the finite automata 2. How to assemble both a DFA, that's what we are doing here. Now how to assemble or to combine these two machines, that's what the procedure that I am explaining. Today's session is about how you do the composition of many machines, right? When you have two different machines, how these two machines can be combined to solve this problem, that's what we are learning Sima today. Fine, and now FA1 cross FA2, we have two machines. How do you combine? So now to combine you should know the principle. Okay, so let me write that here. So I'm going to combine here if anybody want to do combining FA1 Cartesian product with FA2, what you have to do is the Q1 and Q2 you need to do the Cartesian product and sigma is same for both, and delta, with the help of delta 1 and delta 2 we are going to design, and the initial state is going to be a pair A comma X. This will be the pair which will act as an initial state, and final states is going to be a different. Why it's different? Because this F depends on what kind of composition you are doing. Is it AND or but not? This is AND, so this set of final states are going to depend on what condition you want to apply when you combine, right? Even the machine is same for all kinds of combining approaches, but these final states are going to differ. Is it both want to be satisfied, or any of this is fine, or only one of them you want to satisfy? Then that will help us to create the final states. We'll see that how to make the final states later. Now using this concept, first you need to do Q1 cross Q2. That means you need to get the 4 states in the composition. Here 2 states, you will be having 4 states here. I hope you are able to do it now. Q1 cross Q2. What is Q1 cross Q2 here? If you really want to know what is Q1 cross Q2, can you do that? Q1 cross Q2 here. What is Q1 cross Q2? You need to do Q1 is the A comma B and Q2 is X comma Y. Okay, so this X comma Y and A comma B, total you will get 4 pairs like A comma X, A comma Y, B comma X and then B comma Y. It's very easy, right? you have 4 states. Among them you will be having the a comma x as an initial state, and who will be the final, that we will decide at the end. Now how to give the transitions, that we will see now. Let's begin how to do the composition. Now we are designing FA1 cross FA2, and this machine will help us to solve various problems which depends on these 2 conditions. Okay. Now how to design the machine? Total how many states we have? 4 states. What are they? One is, no need write a comma x, just let me write here a, b and x, y. So I am just writing a comma b is same as a b. You can write a b if you want. Okay, this is a one state, and a comma b is not there, sorry, I am very sorry. A comma x, a x, and then a y, b x, b comma x, it's a pair actually, b comma y is a b y. So I am just mentioning in the short form, instead of writing a comma x, I am writing ax. That's, remember that. Okay, they are all same actually, a y. In short form I am writing like this. Okay, do not confuse with this parentheses, all these things. So I am just writing short form. Okay, just to understand easily. Now we have 4 states. Each state has the 2 parameters to understand 2 motions together. Now is here a comma x is the initial state, and now how to give the transitions? If you want to know the transition for, let's say, a comma x, that is ax, okay, that I can write actually for using this concept, a comma x. You want to know for any input I, then how you do it? So first a comma I and then x comma I. So two transitions we are going to apply, 2 transition functions. One on a comma I, that's the delta 1, that's the first motion, and the second motion is delta 2, that's x comma I. So here you will look at a comma I, here you will look into x comma I. So now the I is here either a or b. So for every input you are going to apply the same concept. Here a comma b, here a comma b, here a comma b, here a comma b. 2, 2, 2, 2. Total 8 times you are going to compute the delta. Total 8 times you are going to compute the delta, because for every pair, for every input, because this, you want to design a DFA, right? So for every state and for every input you are going to compute the delta. Delta is a transition function for the composition of these 2 motions. And now if you want to know a comma x, how do you apply a comma x on the small a, lowercase a? So a on a, it goes to b, x on a, it goes to x. So b and x is the result. Let's see, delta a x, that is on a, you want to apply, so you should know delta 1 a comma a and delta 2, that is x comma a. Second motion and first motion. In the second motion, this will give you a comma a is a b, this is a b, and this will give you x. So the result is bx or b comma x. So here is a bx. So I hope if you know how to compute for 1, then remaining all same. A comma x on a, it goes to b comma x. On small b, a on b goes to a, but x on b goes to y. So a y is here, a y is here. So if you use the same concept for every combination, then here a comma x is over, then do for a comma y. A comma y on a, it goes here, on b it goes back, and here b comma x, it goes here, on b it goes here, and b comma y on a, it goes up, and b it goes left. So this is the complete configuration after doing the composition, and this machine is going to help us for many problems. So I am going to copy this for various problems now. Okay, later on I will change it. Okay, so 4 times I am going to use this machine, 4 times, 4 different problems. First problem is, this is the AND. What is this comma represent? What? AND. This comma represent AND. Now for solving AND, I hope you got this point right. For solving this AND, I want to satisfy this condition and also you want to satisfy this conditions. Then you need to look at the pair where here it is also accepted and here also it is accepted. That is what sigma. Which state will be final? You tell me. I want to accept here and also I want to accept here. Now the combined motion should accept to satisfy these two conditions, means which pair will represent the final of this motion and final of this motion, that you should make as a final here. If you look at here, A is the final and here Y is the final. So final comma final pair you are going to look at here, A comma Y combination, this one. So this one you are going to make a final. Why we are making this final? Because you want to satisfy both of them. If it is not AND condition, it is something like OR condition, we have a different way to design. So now because of AND, the final of this new motion, you need to look at the finals will be, the final is nothing but final of FA1 comma final of FA2. This one only can make the final or accepting or satisfying the two conditions. Now look at the A is actually represent number of A's is even, Y actually representing here number of B's is odd. So you want to satisfy both of them, that's why AY is always contain even number of A's and odd number of B's. You check it from here, what strings can halt here? Either 1B means 0 A's and 1B, right? Or you go any path, let's say A, B, A, 2 A's and 1 B. Is it satisfying or not? You take any string which halts here, you start from initial state, you halt here, that string always satisfies these two conditions. Is it clear? So this kind of final of FA1, final of FA2, that kind of pairs will be final in the AND condition. Now the same problem, similar problem, not same, similar problem we are going to see here. This is a different problem I am doing now. Instead of AND, let's say condition is changed. What condition it's going to be? Let's say the condition is, let's say R. Here R is there. R is there. Now it's not comma, it's a something else, right? Here what is they have given? R, O, R. Now this R is different condition now. Here it is R is there, R. Means either you can satisfy this one or both. Now who will be the final here? Who will be the finals? Finals, you have to look for the pair. You have to look for the pair. Any one of them is a final is fine. Like you have to look for final of FA1, or both can be final if you want. This can be non-final of FA2, the second component, and other one, this can be non-final, and the second motion can be final. Or third type is, in the first motion it can be final, in the second motion also can be final. So these three kinds of pairs will definitely accept the string, either A's will be even or B's will be odd, or both can satisfy. Now who are those? At least one final should be there, that either A or Y is there in that pair, either A or Y, except BX, look these three, either A will be there or Y will be there in them. So you can make this R final, that's it. Now it's going to accept R condition, it's going to accept all the strings which satisfies R condition. Is that clear? The same motion for different types of conditions. Is that clear? Now let's go for another one. Now instead of R, let me do for something else. Even but not number of B's of W is equal to odd. It means you want number of A's of W is even, but you don't want this number of B's of W equal to odd. You don't want this, but you want this. Means the string should have even A's, but it should not have odd B's. It means you should find a pair. The final is now you should find a pair. The first component should be final, that is final of FA1, and second component should not be odd B's, means non-final you have to look at, non-final of FA2. So you have to look for the pair where the first parameter should be the final of FA1, second parameter should be the non-final of FA2. That state will accept all the strings where number of A's is even but not number of B's is odd. Now look at who is that. Final of FA1 is A, that is A, and non-final is X. So A comma X. So this one only accepts O's. Is that correct? Yes, only accepts that your requirement. A is the final of this one, means whoever comes here number of A's is even, and X means here, X means number of B's is not odd, means number of B's is even. Indirectly you are trying to say number of A's is even and number of B's also even. Okay, the meaning of this one is number of A's is even and number of B's also even. Clear? That's going to be A comma X. You are going to make the final. In case if the same thing is asked, let me copy this. Okay, let me take another one. So now the question is slightly changed. Here first B's is there, then A's is there, then how you design? Here let's say number of B's of W is equal to odd you want, but you don't want number of A's is even. Then how do you make the final? Now who is the final? Who is the final? The final combination is, this is the first component, right? Number of A's is the first motion. So there you don't want it. So non-final of the finite automata 1 comma, and you want this second motion the strings which are accepted, right? But you don't want to satisfy A's there, remember that. Number of B's should be odd, but number of A's you don't want even. So here final of the second motion. So in the second motion it should accept, but in the first motion it should not accept. That strings you are going to bring out. So who is going to be the final? Who is the non-final of FA1? B. Who is the final of FA2? Y. So you are going to look at B comma Y. That's going to be our final. So B comma Y is here. B comma Y is here. Right. So this is a very interesting pattern in the exam. They may ask you directly many questions. Let's see one shortcut for the exam point of view. See some of the examples, like 1. L is equal to, don't design, not required, don't design at all, just directly you can answer. If they ask number of A's of W is divisible by 2, and maybe I'm just writing for and, but no need to ask for and, or it can ask or it can ask for but not, anything is fine. Number of B's of W is, let's say, divisible by 3. Then what is the answer that you take? Here A's, here divisible by 2, here B's, here divisible by 3. So always look at this condition is over A's, this condition is over B's. That is why we are trying to do the Cartesian product. Thus 2 multiply with 3, you will get 6 states in minimum DFA. So you will always get in minimum DFA 6 states. Okay. Yeah, it's always, you can use always this notation. It could be even for bigger number, use the same concept. Okay, do not try to construct, which will take much time. In number of A's of W is divisible by, let's say, 100, comma or and, doesn't matter. Okay, number of B's of W is divisible by 5. Then answer is just multiply. Answer is just 100 multiply with 5, which is equal to 500 states. 500 states in minimum DFA. But be careful, only for this kind of problems you will be having the minimum DFA is multiplication, but don't use the same formula for all kinds of problems. Some other problems the multiplication will work, but that is not going to be the minimum DFA. This kind of pattern problems here A is divisible by something, here B is divisible by something, and there are no dead states in this, that's why the multiplication is going to work. That's why multiplication of these two states are going to work. Okay, here 2 states comes, here 3 states comes, 2 multiply with 3, 6 states. Okay, but this formula or this concept, please do not apply for any composition. Why? Because you may get a DFA, but you will not get a minimum DFA all the time. Okay, all the time this formula is not applicable. This formula is applicable only when you apply this kind of model especially. Okay, I'll just give hint when you should not apply this formula. Suppose you have a question, note, do not apply this concept like L is equal to W such that W belongs to A comma B whole star, and W starts with, let's say, AA and W ends with BB. So do not use this concept. If you do individually, right, if you do individually, W starts with AA, you will be having a motion like this. Okay, if you have not ever designed, it's fine. Starts with AA, anything is fine, and B will go to dead state because you need to start with AA. So this you will require how many states? 4 states. And W ends with BB. For this, another motion you need to design. Ends with BB means minimum BB, and you will never have a dead state here. Okay, now here A you will wait. After B A comes, you should come back because you need to wait for BB. After BB A comes, again you should start because you want to see BB. After BB any number of B's is fine. So here you will be having 3 states. And what you need to remember, 4 multiplied with 3 is 12. But even though you have 12 state DFA, but that is not a minimum DFA. R is also same answer for that, Asima. I and R but not all are same formula, yaar. Whether it is I and R but not doesn't matter. I already told, right, same answer, it is R but not. Any condition is given here, you are going to use the same formula. Okay, should I write all of them? Not required now. Okay, and I am explaining here R but not all of them, because here A's, there B's, the formula is same for this problem. Okay, now please do not apply the same formula for all, because here there is a condition, here there is a condition, and here you will have 3 states, here you have 4 states. 4 multiply 3, you will have 12 state DFA, no doubt. 12 states DFA is there, but it is not a minimum. DFA exists, no doubt, but it will not be minimum. It will not be minimum DFA here. So that's why here 4 into 3 will not work to find the minimum number of states. Then really anybody want to design? Directly you can try, starting with AA followed by ends with BB. So what is that motion going to be? You see it, very easy it is going to be. You look at it, I am going to design directly. Starts with AA, right? Starts with AA, and minimum string is AA, BB. So this is going to be your minimum string acceptance. And after that, till here it works like starts, and from here it works like ending. So here you need a dead state, because you should start with AA only. So this is the starting, and once you have here, this is ending. Ending exactly looks like this way. So here any number of A's, wait, if A comes, come back always, and after BB any number of B's. This is going to be your motion. How many states you have? 3 plus 3, 6 states total. So for this problem, actual answer is 6 states. 6 states in minimum DFA. If anybody trying to design the 12 states DFA, don't say that is the minimum DFA here. Even though you have 4 multiplied with 3, 12 states DFA is there, but that's not going to be your minimum DFA. So it is one of the important note while you do the composition or while you apply the composition, please don't do blind answer. Multiplication is not going to be the always minimum DFA. Okay, sometimes some of the models, like we have seen in the previous examples, multiplication will give you the minimum number of states in minimum DFA. Okay, but that is not for all kinds of problems. Of course you have a DFA, but it is not going to be the minimum DFA. Okay, Now we have some questions. I hope you got the point right. Now I am giving very important practice questions. I hope you should try now. Very important for the GATE exam point of view. If you can answer this, of course I am giving you difficult questions a little bit, but I want you to try. I want you to try all these questions, but don't blindly answer multiplying. See, always here 0 is there, okay, here 0 is there, here 1 is there. So now blindly you can multiply. So this is talking about zeros, this machine is talking about zeros, this machine will talk about ones, and it's both are divisible by concept. So blindly you can multiply 10 into 20. So 10 multiply with 20, 200 for this question 1. So you can easily do it. But question 2, you see number of zeros is divisible by 10 and number of ones is divisible by 20. Here and is there, right? And is there. Previously what was there? And. Any difference in these two questions? Any difference in this question? Anyone identified? Zeros, ones, any difference? I can't see any difference. Yeah, the difference is like here actually I want to keep the zeros, so here I am going to keep the zeros. So now you will see the difference and note it carefully, note it carefully. Now this is zeros and this is also zeros, and previously this was 1 and this was 0. So one machine is talking about 0, other machine was worried about 1, but in second problem both are worried about zeros. When you do the composition, many overlapping states are there, so that can be combined. So and you are applying and means, see, zeros divisible by 10 and zeros divisible by 20. So you want to satisfy both of them, then why don't you do only 20? 10 also appeared here, right? So and means intersection. Who is the common thing? 10 or 20. If it is divisible by 10, no guarantee divisible by 20. But if it is divisible by 20, guaranteed always divisible by 10. So these two together will happen. Intersection is going to be 20 only. So here don't answer 10, don't answer 200. The answer should be 20. So I want you to understand and answer the exact number of states. And again, so this is zeros, this is zeros, but here divisible by 2 and divisible by 3. Previously it was 10 and 20, there was a relation between 10 and 20, but no relation between 2 and 3. So work on and let me know what is going to be your answer for number of zeros is divisible by 2 and number of zeros divisible by 3. And when you do the composition, will you get 6 states or less? Okay. Minimum DFA only you need to answer. Remember, the question is asked only for minimum DFA. And another one, this is zeros divisible by 2 and this is zeros divisible by 4, and this is AND condition. Okay, and or but not all will be different answers here. Remember, and or may not match sometimes. Now here zeros divisible by 2, zeros divisible by 4, and you want to do intersection, means which one will satisfy both of them. If I take 2, 6 can divide by 2, but 4, the 6 cannot divide with 4. 6 cannot be divided by 4. So now if I take a 4, all multiples of 4 definitely divided with 2. That means divisible by 2. So now this equal to the divisible by 4 only. So somebody want to ask divisible by 4, but they confused a little bit by writing more conditions. I want to divisible by 2 as well as divisible by 4. It means just divisible by 4 only. So here the answer should be like 4 states, but why? Okay. So now the question number 5 is zeros divisible by 1 and zeros divisible by 3. So just look at what is going to be the common property. Okay, I want to satisfy both of them. Okay, maybe I have written the AND for all, but you can also try for OR, but not all these things on your own. Okay, I hope in this session you got to know how to understand the composition of DFAs. If you have more than one condition, let's say even it could be 3 conditions. So each condition you can design a finite automata and then look at how you want to do the composition of the constructed machines. Okay. Yeah, thank you so much for attending this session and see you tomorrow with another topic in theory of computation. Bye bye, take care.